When you eat an apple, what happens to it? Chemical reactions occur inside your body and break down the apple. This provides you with the energy and nutrients you need. Hi, and welcome back. In today's science episode, I will talk about chemical changes.
Chemical changes. Introduction. A chemical reaction is a change in which one or more substances are converted into new substances. The starting substances that react are called reactants. The new substances produced are called products. This relationship between reactants and products can be written as follows: reactants produce products. Lavoisier and the conservation of mass. Antoine Laurent Lavoisier, a meticulous experimenter, revolutionized chemistry. He established the law of conservation of mass. It states that mass is neither created nor destroyed in chemical reactions. Writing equations. A chemical equation is a way to describe a chemical reaction, using chemical formulas and other symbols. Some of the symbols used in chemical equations are listed in Table 1. Symbols used in chemical equations. If you see an arrow, you can read it as produce or yields. This symbol represents plus, S solid, L liquid, G gas, AQ aqueous, a substance is dissolved in water. If you see an arrow and the word heat on top, it means that the reactants are heated. If you see an arrow and the word light on top, it means that the reactants are exposed to light. If you see an arrow and the abbreviation ELEC, it means that an electric current is applied to the reactants. Coefficients. Notice the numbers next to the formulas for sodium hydroxide and sodium chloride above. What do they mean? So here we can see that there is a number 2 before sodium hydroxide, and here we have a number 2 before sodium chloride. What does that mean? These numbers are called coefficients, and they represent the number of units of each substance taking part in a reaction. And just for you to be clear, these are the coefficients. They are before, right, the elements. Now, this one that we have here is a subscript. It's not a coefficient. Don't confuse them. When no coefficient appears before a substance in a balanced equation, a coefficient of 1 is assumed. In the equation above, for example, 1 unit of nickel 2 chloride combined with 2 units of sodium hydroxide. The products were 1 unit of nickel 2 hydroxide plus and 2 units of sodium chloride. Remember that according to the law of conservation of mass, atoms are rearranged but never destroyed in a chemical reaction. Notice in the equation above that there are equal numbers of each type of atom on each side of the arrow. Balancing equation. Lavoisier-Mercury second oxide reaction can be written as you can see here. Notice the number of mercury atoms is the same on both sides of the equation, but the number of oxygen atoms is not. So, when you have to balance an equation, the first thing you can do is a chart like this one. So you write the formula and the atoms that you have. We have mercury and we have oxygen on both sides. That's the only ones you can see, mercury and oxygen. Then we count how much do we have on each side. On this side, I have only 1 mercury. On the other side, that means after the arrow, I have 1 mercury. So we can say it's balanced. Now let's see oxygen. On this side of the equation, I have one oxygen. Okay? We don't have a coefficient, we don't have a subscript, so only one oxygen. But on the other side of my equations, I have two oxygen atoms. So that means this equation is not balanced because there are more oxygens on this side. In this equation, one oxygen atom appears on the reactant side of the equation and two appear on the product side. But according to the law of conservation of mass, one oxygen atom cannot just become two, nor can you simply add the subscript 2 and write the following formula, or this one instead. This formula and this formula do not represent the same compound. In fact, this formula does not exist. The formulas in a chemical equation must accurately represent the compounds that react. Fixing this equation requires a process called balancing. Balancing an equation doesn't change what happens in a reaction. It simply changes the way the reaction is represented. Choosing coefficients. The balancing process involves changing coefficients in a reaction in order to achieve a balanced chemical equation, which is a chemical equation with the number of atoms of each element on both sides of the arrow. In the equation of Lavoisier's experiment, the number of mercury atoms is balanced, but one oxygen atom is on the left and two are on the right. Oxygen can be balanced by placing a number 2 before this formula on the left, then placing a 2 before this formula on the right. This will balance mercury. So now you can count. In this case, we have 2 mercuries, and on the other side, I have 2 mercuries. And I will also have 2 oxygens, okay, on both sides of the equation. Let's practice now. Try your balancing act. Magnesium burns with such a brilliant white light that is often used in fireworks. Burning leaves a white powder called magnesium oxide. To write a balanced chemical equation, follow these steps. Step 1. Write a chemical equation for the reaction of magnesium with oxygen. Recall that oxygen is a diatomic molecule. So here we have the chemical equation. Step 2. Count the atoms in reactants and products. The magnesium atoms are balanced, but the oxygen atoms are not. So remember the recommendation I gave you. First, make a chart like this. List all the elements that you have, and then how much do you have of each one. So magnesium, we have here 1, look, and on the other side we only have 1. Now on this side we have 2 oxygen, and on this side I only have 1. So I need to balance the number of oxygens. Choose coefficients that balance the equation. Remember, never change subscripts of a correct formula to balance an equation. Try putting a coefficient of 2 before magnesium oxide. So this number, the subscript, I can never change this. Now, if I wrote a coefficient of 2 here on the other side, this will balance oxygen. So let's count how much of each element we have now. Of magnesium, I have 1 here. And now, on the other side, I have 2. What happened with oxygen? Here I have 2. And now on this side, because I wrote this coefficient, we can say that this coefficient multiplies by the 1 we have here. So I have 2 magnesiums and 2 oxygens. Oxygen is balanced. We have 2 and 2. Now, which element is not balanced? Magnesium. So now we have to balance that part of the equation. And here is another tip for you. When you have an equation, they can be even longer than this one. First, start by balancing oxygen or hydrogen if you have them. That will make things much easier. It's a tip that I'm giving you. We check the numbers of each atom on each side of the equation and adjust coefficients again if necessary. Now to magnesium atoms are on the right side and only one is on the left side. So a coefficient of 2 is needed for magnesium to balance the equation. I add here the coefficient 2. Now let's check how much we have of each element. 2 magnesiums here, 2 magnesiums, 2 oxygens, and 2 oxygens. So I can say that my equation is balanced.
I hope you found this video interesting. Thanks for watching and until the next one. Bye!